I welcome you all back to class. Today we'll be taking our lesson 5, and this lesson 5 is on the binary number system. The binary number system. This lesson is so big, is so important. This lesson is the heart of information technology. Anyone who wants to understand IT or has passion for IT or desires to know anything about IT must break down this lesson first. In other words, you must understand this first, because this is ICT. We are talking about the binary number system. We are talking about the building blocks of technology. In the binary system, this is what you see. In the binary system, it's all about what you are seeing on the screen. Information technology is made up of exactly what you are seeing. Everything in IT is about exactly this. There is nothing in IT that is something else. Everything is about this. From our electrical signals that runs through the computer to the processing in the CPU, to the data we store, to the images we see, the sound we hear, and the data we communicate through the air and through cables. They are all ones and zeros. All of them. The electrical signals running through your computers are zeros and ones. Even the electricity are zeros and ones. Any calculation that needs to be performed is performed in zeros and ones. When you store data, your data is stored as zeros and ones. No matter what you have and what you want to store. If it's a Word document, you are seeing a Word document. The computer doesn't see a Word document. The computer sees zeros and ones. The text you see on your screen are all zeros and ones. The pictures you see, even the videos you watch. Have you ever watched a video? Let me tell you, the videos you are watching are just zeros and ones that are being interpreted in the form of video, and that is amazing and mind-blowing. The sound you hear, when you hear sound, they are just zeros and ones being converted into vibrations. And the output device designed for sound is able to send those vibrations, and they become sound in your ears. This is technology. You can never study IT without this lesson. And no matter the level of IT you want to be exposed to, you will be exposed to a level of this. This is called binary. This binary was taken out of a number system. We have several number systems in the world. The one we are trained with as humans is called a decimal number system. When we were born, we were trained with the decimal number system. The decimal number system is made up of 10 digits, starting from 0 to 9. Any number you want to imagine will come out of those 10 digits. And we understand decimal very well. We know it very well because we were trained with it from birth. If I ask you 5,000 plus 200, you can give me an answer immediately. Your brain will process that information in a second, because you understand that number system. But if you were not trained with that number system, you will not be able to give me the solution to the simple arithmetic question I just gave you. That same way, there are other number systems that probably you have never heard of and you've not been trained in, and so they may sound strange to you. Have you heard of the Roman numerals? Have you heard of Roman numerals? It is also a number system. Maybe you don't know much about it, but it's a number system that can be used for counting. And there are other number systems. In all of IT, there are 4 number systems that impact the world of IT, because technology is dealing with humans. And so for technology to deal with us very well, and for all of us to be able to operate effectively, there are 4 number systems that we make use of when we as humans are dealing with computers. Nevertheless, binary is a core. The other number systems are just being used to make things look easier to us. But in the computer, it's all about binary. The other 4, or the 4 binary systems, the 4 number systems I'm talking about are: number 1, decimal. And I've already talked about decimal. You know decimal is base 10. Base 10 is made up of how many digits? 10 digits. And anytime you say 10 digits, it starts from 0, so it will end at 9. Think of any number. You will see that the number is made up of digits from 0 to 9. There is no other character or symbol that will appear in any number you can think of. It is just 0 to 9 that you will find, different orders. Number 2, we have what we call hexadecimal. Let me write them down. So I said we have decimal, and decimal is base what? Base 10, and is made up of digits from 0 to 9, right? Number 2, we'll talk about hexadecimal. It's called base 16. When you hear base 16, it's made up of 16 digits that starts from 0 to, who can tell me? Excellent. You are already smart. That means you can understand this topic very well. Let me tell you about the third one. Okay, just a second. Talking about base 16, if someone here is curious, you ask me, how in the world do we have 16 digits? How do we get 16 digits? Because we only know of 10 digits as humans. When we are counting, we start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many digits do I have on the screen? 10, right? The symbols for numbers are finished. Is there any other symbol I can use for the next digit? If I say 10, 10 is just 1 and 0. I'm repeating. We are not repeating here. 11 is 1 and 1. I'm repeating. So in base 16, how in the world do they have 16 symbols? Let me tell you about this amazing number system. It's so interesting. In base 16, they start from 0. When they get to 9, to move on, the next number is this. This is 10 in hexadecimal number system. If you are thinking in this number system, or you are working in this number system, there is nothing like 1 0. This is what we use. A. What is the symbol for 11? It will be B. 12, C. 13, D. 14, 15, 16. Okay, I expected you to tell me that we can't have 16. Because base 16 must begin from 0 and end at what? 15. Please, are you here? Base 10 must begin from 0 and end at what? Anytime you see any code and they tell you that this code is base 16 code or is hexadecimal code, and you see 16 among the code, it is a big error. It's not possible. In hexadecimal, these are the numbers, and these things have meaning when you are dealing with those languages or those number systems. After you are acquainted with what we are about to learn today, you will get into hexadecimal and you see that, wow, education can be advanced, and I can know and think in a different number system. Hexadecimal is so amazing. I like it. Let me tell you about the third one. The third one is very simple. It is called the octal number system. Octal number system, to just explain it, I'll just tell you that this is base 8. A base 8 number system. And who can tell me the digits in base 8 number system? Begins from 0 to what? Excellent. You can never find a base 8 number system that has the number 8. Anytime you see number 8, it is cancelled. This is not a base 8 number system. Maybe it's decimal number system. We don't have 8. 8 does not exist in the world of octal. Hello. I said 8 does not exist in the world of what? It ends at 7. Now, if I'm allowed to use this word, the almighty number system for information technology is a number system called binary. Binary is base 2. And who can tell me the digit found in base 2? 0 to what? Do you understand now? We can never see the number 2 in a base 2 number system. You can never see the number 8 in a base 8 number system. You can never see the number 16 in a base 16 number system. You can never see 10 in a base 10 number system. Because the digits begin from 0 and end at -1 of the number system, of the base. That is why today our lesson is going to be about this. If you love IT, you need to pay a little attention to this number system, because it is a number system. A number system means it can be used for numbering and counting. Any value can be created with this number system. If you want 5,200, you can count up to 5,200 in this number system. How do you do it? You have to be trained in it. You may not have been trained in this number system. This is what you have been trained with, and you know it so well. You can even count in your sleep. Sometimes you even dream that you are counting. But in this number system, let me tell you, you have to now become a child to start learning how to count. Do you remember when you were a baby and you started learning 1, 2, 3? Do you remember? Maybe you don't remember your own, but you remember other children. When they started learning 1, 2, 3, 4, 5, 6, 7, 8. Today, you too have to become a child and start learning a different system. That system is a base 2 system. How do we write 3 in a base 2 system? 3 has to be written in base 2. How do you do it? Are you ready to learn a new number system? Or you don't want to grow in your understanding? Hello? Or you want to remain where you are? Hello? For me, I can operate in all these 4 number systems. I don't know whether you want to learn something new, but if you love IT, you have to learn. I'm trying to find a calculator because sometimes on calculators you see certain codes that you don't understand. I have a calculator here on my phone. I can see these codes, and you can find these codes in every scientific or programmable or programmer calculator. And this code is what I want to show you. Let me just try and show you what I'm seeing here. I'm seeing something here. I don't know if you can see this on the screen. Can you? What do you see here? When I pick my calculator, I can see that they've written somewhere in yellow, hex. At first, I didn't know what it meant until I studied about hexadecimal number system. Oh wow, I can convert my calculator to hex and calculate in hex number system. Wow. The second one is what? Dec. Dec stands for what? Decimal number system. And you see that that one has been highlighted. I can see a selection here. Maybe it's not showing on the projector, but something here is telling me that right now the calculator has picked Dec. So all the operations in the calculator will be happening in Dec. That's why when you calculate, you see the answer you understand. If you change the number system, the answer you get, you may not understand. You say 50 plus 70 and they'll tell you something else and you'll be surprised because you don't understand the number system you're operating in. Wow. The third one you see is what? Oct stands for what? Octal number system. And I said that one is base what? Base what? Base 8. Then you can see bin. Bin stands for what? Wow. Binary number system. I can convert my calculator to binary number system and calculate in binary. In digital electronics and information technology, these are the 4 systems we have adopted for numbers. And if you want to be a genius, you want to be a scientist, you want to be a computer engineer, these are the 4 number systems you have to delve into and study about. Are you with me? The most important one of them all is the binary number system. I love to know more about the binary number system. I really want to know more about binary. How can I learn binary? That is why we are here. I don't know if this is trying to take my time, but I've just changed the number system and I've told this particular calculator to operate in hex. When I did, look down here, they have given me several characters here. Watch this. I can punch numbers from 0 to 9, and I'm seeing A, B, C, D, E, F. Do you know that they are all numbers? Oh, I don't know if you can see. Do you know that all these are numbers in the hex system? I told the calculator to operate in hex, and it has made all these numbers available to me. If I didn't know anything about hex, I'll be asking, what the hell is A? But A is a number in this number system. Let me tell the calculator to operate in oct, and we'll see what will happen. So let's tell the calculator to operate in oct. Do you see that these ones are faded? Can you see that they are faded? I'm sure you can see. Watch this. Do you see that other numbers are... Oh, come on. Do you see the other numbers are faded? Do you see that this is faded? Can you see? Do you have eyes? Can you see this? What do you see here? What do you see here? Do you see that 9 is faded? Are you sure you can see? Who can tell me what that means? What's the meaning of that? What is the meaning of that? What is that supposed to mean? What is that supposed to mean? Who can tell me? Yes. 0 to 7. Come again. Because the octal number systems only operate with 0 to 7. We don't have number 8, so the calculator will not allow you to punch 8 because it does not exist. It does not exist. Let me tell you, if you were born in a country where they only teach oct, you will not know that symbol called 8. 8 will not be in your mind. 8 will not exist to you. The way you only know up to 9. Right now, you only know from 0 to 9. You don't know any other symbol that means another thing. And you can do all your counting between 0 and 9. That same way, if you were in an oct world, all your counting will be from 0 to 7. Now, let's switch to the bin world and see what the IT people will tell us. When I switch to bin world, I don't know if someone can see what is happening. In the bin world, watch this. Can you see something? Who can tell me what you see? In the bin world, what do you see? Pardon? You only see 0 and 1, right? That means these are the only numbers or characters or symbols that exists in this world. 0s and 1. And all your counting must be done with these 2 digits. All your countings, no matter the number, and you can get up to millions and billions and trillions and whatever, all in 0 and 1. How do you do that? It may sound difficult because you were not trained with this when you were born. But if you want higher education, you need to start learning something new. Do something new in my life. Something new in my life. Something new in my life. Oh Lord, do something new in my life. Something new in my life. Something new in my life. Oh Lord, I cannot do without you. I cannot do without you. I cannot do without you. Oh Lord, I cannot do without you. I cannot do Without you, I cannot do without you. Oh. Do you want to learn something new? Are you sure? Are you very sure? Or you want to remain where you are? Okay. All right. So let's get into this new world of binary. What is binary? What is binary? The binary number system. Now, introduction. Binary is a base 2 number system that is made up of only 2 numbers, into brackets 0 and 1. It is the simplest kind of number system in the world. Computers work with the binary system to process and store all of its data using binary codes. The CPU processes millions of binary codes in order to store information or even render an output in the form of text, images, and sound. Binary is the most basic language of computers. It is actually the only language that computers understand. I repeat that. It is actually the only language that computers understand. All other programming languages, such as Java, C++, PHP, HTML, and XML, were created from binary. And all sort of instructions or commands are given to computers for processing and storage in binary. If you have questions, I'd like to hear your questions. By using binary, computational problems can be solved by computers because in digital electronics, a transistor is used in 2 states, either off or on. Those 2 states can be represented in 0 and 1, making binary the preferred mode of electronic transmission, processing, and data storage for computers. This is so amazing. We all know that when the transistor was discovered, a lot happened in the advancement of computers. Immediately the transistor was discovered, it was upgraded to the integrated circuit, which made use of several transistors on one chip, and the same transistors were upgraded to the microprocessor, which is the CPU we use. If you look into the CPU is made up of transistors. Millions of transistors. And this transistor or transistors operate in 2 states. Because of that, computers found the binary number system as an amazing system or the perfect system to work with computers. And so because we can operate in just 2 states, we can use these 2 states to represent anything we want when we do complex calculations. Complex. Have you seen a computer network cable before? Maybe you've not seen a network cable. Have you seen a fiber optic cable before? Maybe you've not seen a fiber cable before. But let me tell you something. You've all sent data through the internet before, right? Hello. Let me tell you how your data goes to a different computer or to the internet. Listen. We can use a wire to transmit any data we want to transmit to someone, to somewhere else, or to another computer. Do you know what we have to do? All we have to do is to switch the wire on or off. On or off. On or off. Now watch this. If I keep switching the wire on, off, I'm sending numbers. By the wire coming on and off, the numbers should be recorded. On means 1. Off means what? Off means what? 0. So if they just use power, electricity that you know, and switch a wire on, off, on, off, on, off, on, off, on, off, at the end of the other computer receiving the data, that computer will only receive 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. When the data transmission is done, that 0, 1 means a picture or an email or your Word document. Whatever you are trying to communicate, it is 0 and 1. That is how data is transferred through wires. They can use electricity to send data. Amazing. Because everything is in 0 and 1. Fiber optics is a new kind of wire that doesn't use electric lines, but uses light. And because light travels fast, our main internet makes use of fiber optic cables. Do you know what happens when we are transferring data with fiber optic cables? We just on light. Light is just light. Do you see light? Light traveling through a wire, a cable. The cable is sealed. If you have never seen fiber optic cables before, this is how they look like. What is inside the fiber optic is light. Light is what travels through it. Now, when you switch light on, off, on, off, on, off, on, off, just light, you are transmitting data. So all the data we are transmitting, they are transmitted as light. Just light. The receiver will record the on state as 1 and the off state as 0. On, off can give us anything, any data. This is how technology works for us. Maybe you are using it, but you don't know how it's designed. Hello. This is technology. And if you are told how we communicate through the air, if you are told about that, let me tell you, you may go crazy. If you are told how we communicate through the air, we send data through the air. If you are told how that happens, the day you learn about this, what I'm searching for right now is called the electromagnetic spectrum. Oh my God. The day you will learn about the electromagnetic spectrum, you are going to lose your mind. The day you will upgrade your knowledge to the level of the electromagnetic spectrum, you are going to go crazy. You are going to lose your mind. What do you see here? Radio. What do you see? What do you see? What do you see? Oh my God. What do you see? What do you see? What do you see? The day you study about this, you are going to go crazy. In the invisible atmosphere, there is something called the electromagnetic spectrum that scientists have discovered. When they found this, it made it possible to transmit anything through the air. There is a certain frequency of the electromagnetic spectrum that can transmit radio waves. And that is what we use to transmit FM radio at various frequencies, 92.5 megahertz. Or whatever megahertz. At another frequency or level of the electromagnetic spectrum, we have microwaves. At another level, we have infrared. And this infrared too, we have made use of it to transmit data. At another level is the visible light. That is the level your eye can pick for you to see light. Let me tell you, the day you will learn about this, or you will understand what you are seeing on the screen, you are going to lose your mind. You will see what scientists have discovered in the atmosphere that we have in this world. And we make use of the electromagnetic spectrum to run X-rays and a whole lot. I don't expect you to understand anything about electromagnetic spectrum right now. But if you are curious, start asking questions. Because if you want to understand how things move through the air, how radio, TV runs through the air, how data can be sent through the air, how your Bluetooth can receive data, how Wi-Fi works just through the air. This is it. And this covers everything that travels through the air, what you are seeing. And let me tell you, I don't expect you to understand anything. Whatever I'm saying, you'll not understand it. But if you are curious, start asking questions. The day you understand this, you will lose your mind.
Hi, my name is Madison Maxey. I have a company called Lumia, and we focus on making smart fabrics for smart clothing and smart soft good products. The sky's the limit when it comes to textiles.
My name is Danielle Applestone, and I'm CEO of Other Machine Company. We build a desktop milling machine. A milling machine takes a rotating cutting tool and moves it through material to create a 3D object.
Under the hood, all computers do the same 4 basic things. They input information, store and process the information, and then output information. Each of these things is done by a different part of the computer. There are input devices that take input from the outside world and convert it into binary information. There is memory to store this information. There's a central processing unit, or CPU, where all the calculations are done. And finally, there are output devices that take information and convert it into physical output.
Let's talk about input first. Computers can take many different types of input, like the keyboard of a computer, the touchpad of a phone, a camera, a microphone, or a GPS. But even the sensors on a car, a thermostat, or a drone are also different input devices. Now let's look at a simple example of how input travels through a computer and becomes output. When you press a key on your keyboard, let's say the letter B, the keyboard converts the letter to a number. That number is sent as binary, ones and zeros, into the computer. Starting from this number, the CPU calculates how to display the letter B pixel by pixel. The CPU requests step-by-step instructions from memory which tell it how to draw the letter B. The CPU runs these instructions and stores the results as pixels in memory. Finally, this pixel information is sent in binary to the screen. The screen is an output device, which converts the binary signals into the tiny lights and colors that make up what you see.
This all happens so quickly it feels instantaneous. But to display each letter, a computer runs thousands of instructions, starting from the moment your finger presses the keyboard.
In that example, the output device was the screen. But there are many different types of output which take a binary signal from the computer and do something in the physical world. For example, a speaker will play sound, and a 3D printer will print an object. Output devices can also control physical motion, like a robotic arm, the motor of a car, or the cutting tool of the milling machine that my company makes. New types of inputs and outputs let computers interact with the world in entirely new ways. This has been helped out by improvements to the speed and size of the memory and CPU. The more complicated a task is, and the more information that's input or output, the more processing power and memory a computer needs. Typing letters on a screen may be easy, but to do complicated 3D graphics or record a high-definition movie, modern computers often have multiple CPUs to process all that information, and many gigabytes of memory to store it.
No matter what it is you want to do with a computer, every single action is about inputting information from the physical world, storing and processing that information, and getting some output back into the physical world.
If you lift the lid of a computer, you will see a circuit board into which a number of little boxes have been plugged. Each box contains a chip, which consists of thousands of microscopic electric circuits, each of which can be either on or off. This is the only language that the computer understands. Is one of my circuits on or off? A sequence of several ons and offs in various combinations can represent any number or letter or graphic symbol, and we can symbolize these ons and offs by using a 1 to stand for on and a 0 to stand for off. Most computers can represent any of the symbols on their keyboards by various combinations for a total of exactly 8 ones and zeros. Since this language or code is based on 2 digits, 1 or 0, just as a bicycle is based on 2 wheels, or a biplane is based on 2 pairs of wings, it is called the binary code, from the Latin word binarius, meaning 2 together, and each of the ones and zeros is called a binary digit, or bit for short. So it takes 8 bits to represent any keyboard character. Such a group of 8 bits is called a byte. 1 byte is the equivalent of 1 character. This computer can store or remember roughly 32,000 bytes. That means you can feed a program into it that uses up to 32,000 characters, letters, numbers, or graphic symbols. Just as a kilometer is 1,000 meters and a kilogram is 1,000 grams, so is a kilobyte roughly 1,000 bytes. This computer, therefore, has a 32 kilobyte memory, or a 32K memory for short. But the memory of most small personal computers can be extended to at least double that, 64K. This may sound a lot, but it isn't. The average page of a book contains about 2,000 characters. It's a 2K page. So even a 64K computer can only store as many characters as a 32-page book. And a 32K computer only as many as a 16-page book. Although, of course, a computer can do a lot more with its characters than a book can. But that's another story.
All right, so in this video, we just heard how olden days computers did their things and the amount of memory they had. Those days computers had 32K memory, 64K memory. You can't imagine that today. But you can see where he started from. And this explains the basics of binary. First, computers make use of this number system because all our electronics, our hardware and software will be able to conform and accept this method. And so that is what has been adopted. The next part is that everything we see on our screen is made up of this code, a group of them. Whether we see numbers or text or images, they are all made up of this code. The next thing to understand is that these codes in IT, listen again, operates in groups of 8 at every point in time. Take that seriously and put that in your mind right now. This code in IT or in our computers, in our PCs, are designed to operate in groups of 8 at every time. Listen, each of these is called a binary digit. Each one is a binary digit. This one right here is a binary digit. This is also a binary digit. This is also a binary digit. They are all binary digits. If binary digit sounds a mouthful and is difficult to pronounce binary digit, you can shorten it and call it bit. Bit. Have you heard bits before? Bits. Have you heard bits before in IT? Bit, that's what it stands for. It stands for what? Binary digit. A single binary value. It can be 0, it can be 1. Bit stands for binary digit, and it is a single binary value, either 0 or 1. Hello. Now listen to this. I told you that computers have agreed that for our bits to be used, they have to be used in groups of 8 at every time. Now this group of 8, we always take them and we bundle them together. And we have given a name to the group of 8. That name is byte. That name is what? Who can spell byte? It is not B-I-T-E, as in biting, biting a meat pie or biting chocolate. No, that's not it. It's not B-I-T-E. Who can tell me? It is B-Y-T-E. Byte. Have you heard byte before? Now, this byte is what we actually measure our data storage in. Have you heard of kilobyte? Have you heard kilobyte? It means it is 1,000 bytes. Hello? Have you heard of megabyte? It means million bytes. Have you heard of gigabyte? It means billion bytes. Are you with me? Have you heard of terabyte? That means we store our data in bytes. But I want to take your mind there. This byte is a bundle of bits. How many bits has been grouped together to give you a byte? 8. Now let me tell you, your data is stored in bits, but they are counted as bytes. Hello? Your data is stored in bits, but they are counted as what? Bytes. That is why it is hard to find on your computer that this file is 2 bits. You will not see 2 bits. You will see that your file is in bytes, right? Do you have a pen drive? What is the size of your pen drive? 64 what? Gigabyte. Did you hear gigabytes? Or you heard gigabits? What did you hear? That means your pen drive can store up to 64 gigabytes of data. Now, we are telling you that even though we operate in bits, we count our data storage in bytes. I'll tell you why. Why did we do that? Let's go into the lesson. Bit and byte. The term bit stands for binary digits. It is a single binary value, either 0 or 1. And it is the smallest unit of data in a computer. 8 bits together make up 1 byte. 8 bits together make up what? 1 byte. So 0 is a bit, 1 is a bit. Hello? Let's talk about byte. A byte is the smallest addressable unit of computer memory. A byte is the smallest addressable unit of computer memory, consisting of how many bits? 8 bits. Since computers work with 8 bits at a time, byte is the smallest unit addressed in computer storage. Byte. So this code here are 8 bits put together, but we call them what? Hello. When I tell you to perform a binary calculation and leave your answer in 8 bits, this is how your answer will look like. It will be 1, 2, 3, 4, 5, 6, 7, 8. This is 8 bits. When you see 8 bits, you will find 8 digits. When they say 16 bits, how many digits will you find? 16 digits. When I say 4 bits, how many digits will you find? 4. Are you with me? So put this in your mind. We store in bits, but we operate in bytes. Can you understand that? Does that make sense to you? Let's talk about the history of bits and bytes. Listen. In computer history, 8 bits were used to encode a single character of text for the keyboard. This is why we decided to operate in 8 bits. Let me rephrase that in basic language. Listen to me. When they were trying hard to use bits to form human characters, Characters that humans can relate with. Hello? Hello? When they were trying hard to use bits to form human characters, because binary code, when we start putting things together, they become too plenty for humans to understand. And so when they were trying to put bits together to form characters that humans can relate with, they eventually use 8 bits to be able to form a single character. They eventually use 8 bits to form a single character. And so it was accepted that computers will operate with groups of 8 bits. Because every character on your keyboard occupies 8 bits of memory. Every character occupies 8 bits. When you press anything on the keyboard, it occupies 8 bits. Hello? For this reason, 8 bits are addressed together as 1 byte. In other words, 8 bits are used to represent every keyboard character, whether text, number, or symbol inside a computer memory. Which is why a byte is the smallest addressable unit of computer storage. Are you here with me? Let me give you a quick experiment. Are you here? Hello? Let me run my notepad. And this notepad is an amazing program. It's a plain text editor. It doesn't add any extra code to what you store. Are you with me? I'm going to store a single letter in computer memory, and we'll check how much space this letter will occupy in the memory. Are you with me? Should I save this? I'm going to save. I click on File and Save. Let me save it on the desktop so that it will become easy. I'm going to call it binary storage. I'm just calling it binary storage. I've stored it on the desktop, and let me see where, let me look for it on my desktop. It's supposed to be here. Binary storage. Let me press B. When you're looking for something on your desktop and you can't find, just press the first letter of that file. So B. Oh, I found it. It's right here and I couldn't find it. Have you seen it here? Let me zoom in. Have you seen this file? Have you seen this file? What is inside it? Just one letter, right? Just one. Do you remember? Let's check how much space is occupied. To check the space of anything, right click and go to Properties. Properties. Let's see. What is the size? What do you see here? 1 byte. The file size of what I have stored is 1 byte. Wow. Wait a minute. So letter A alone occupies 1 byte of computer memory. When you have a lot of text and you want to find out how much space they occupy on your machine, each letter is 1 byte. So if your essay or your text is made up of 2,000 words and let's say 10,000 letters, that means each letter will occupy 1 byte. So 10,000 will be 10,000 bytes. That will be 10 kilobytes. So if you write text of 10,000 letters, it's going to occupy 10 kilobytes, and we know it. Because each letter, whether it's a letter, now you see 1 byte, right? Let me open it again and let me add something to it. Let me add 1. Let's see how much it will be now. I've added something else. This 1 here, see, now you understand this. Let me check the file size again. How much space has it occupied? 2 bytes, right? Let me add a symbol. Let me add this symbol. Let me add this. What do you see? How many characters do you see? 5, right? Okay, so these 5 characters, let's check how much space they occupy. How many? 5 bytes. That means every character on your keyboard is occupying 1 byte. So what we are trying to tell you is that when they were designing the keyboard, or how to form characters that humans will understand, they were able to achieve that by using 8 bits. And so it was standardized that 8 bits will be used to represent each keyboard character. Whatever you press on your keyboard will occupy 8 bits. So instead of working in groups of 8 bits, 8 bits, 8 bits, 8 bits, 8 bits, 8 bits, we decided that wait a minute, let's group these 8 bits and start from 1 with it. So instead of calling it bit, we gave it a name and we call it what? We called it what? Byte. So now we can say 1 byte. When we say 1 byte, we are saying 8 bits. Are you with me? Quick exercise. How many bits will 5 bytes give you? Calculate that for me now. Pardon?
40.
How did you get 40? 8 by what? 8 by 5. Okay. Okay. Now, let me give you another quick exercise. There is a certain photo. That photo is occupying 7 kilobytes. Or the size of the photo is 7 kilobytes. How many bits makes up the 7 kilobytes? Because even though you are seeing 7 kilobytes, it will be stored in bits. How many bits makes up the 7 kilobytes? Calculate that for me now. 56,000 bits. Do you agree? The photo is occupying 7 kilobytes, and you are asked to convert this 7 kilobytes in bits. How many bits will you get? 56,000. How did you get 56,000? Okay, wait a minute. So first of all, listen to what they are saying. Are they saying kilobyte, megabyte, gigabyte? That is where your first clue will come from. What did you hear in the question? The question said, what was in the question? Was it megabyte or gigabyte? What was in the question? Kilobyte. Kilobyte was in the question. Now, kilobyte alone, the kilo means 1,000. Kilo means it has already been multiplied by 1,000. So when they say 7 kilobytes, first of all, you ask yourself how many bytes? It's going to be 7,000 bytes. Instead of saying 7,000 bytes, we say 7 KB or 7 kilobytes. But 7 kilobytes is the same as 7,000 bytes. Does that make any sense to you? Now, this 7,000 bytes, how do you move it into bits? You multiply them by 8, right? So 7,000 bytes times 8 will give you what? 56,000 kilobytes. Is that correct? 7,000 bytes. Now I can't operate because I'm in bin. Let me move to deck. Okay, so 7,000 bytes times 8 equal to 56,000 bits. So it will take 52,000 bits to store that photo. Wow. Can you imagine the number of ones and zeros? 52,000 ones and zeros to store your photo. And if you are using a modern camera today, that stores in megapixels and 16 megapixels, 32 megapixels, then don't go there. All right. Let me chip this in. Let me chip this in. Four bits. I didn't talk about it in my book. When you're advancing a little in IT, you will be operating a little, or you do some work in 4 bits. 4 bits. 4 bits. Sorry. 4 bits is called. 4 bits is called a nibble in IT. 8 bits is called bytes. So I'm just chipping this one in for you to just store it somewhere, because later in future you may be asked what 4 bits stands for. All right, now watch this. Now we said 8 bits is what? 1 byte. 8 bits is what? Now come and let's learn this. We are come to learn something serious. Let's keep this in mind. 1,000 bytes is equal to 1 kilobyte. Okay, so when we said 7 kilobytes, how many bytes did we get? 7,000 bytes. Okay, good. So now you understand. Now 1,000 kilobytes is called 1 megabyte. Have you heard of megabyte before? Good. 1 megabyte means 1,000 kilobytes. Now how many bytes is 1 megabyte? I didn't say how many kilobytes is 1 megabyte. How many bytes is 1 megabyte? 1 million. How did you get 1 million? Okay. Now we are saying 1,000 bytes will give you 1 kilobyte. So this 1 kilobyte is already 1,000 bytes. And we are saying 1,000 kilobytes is 1 megabyte. Now how many bytes will give you megabyte? 1 megabyte. It is 1,000 times 1,000. 1,000 times 1,000. Meaning 1 million. 1 million bytes. Now when I ask you how many bits will give you 1 megabyte, what will you say? If 1 million bytes will give you 1 megabyte, how many bits will give you 1 megabyte? How many bits will give you 1 megabyte? We've already told you that 1 million bytes will give you 1 megabyte. Just convert 1 million bytes to bits and you have your answer. 8 million bits is the correct answer. Now listen, 1,000 megabytes will give you 1 gigabyte. Now 1,000 gigabytes makes up what? Makes up what? 1 terabyte. Now do you have a pen drive? You say your pen drive is 64 gigabytes, right? 64 gig. It's normal. We've been hearing 64 gig, 32 gig, 16 gig, 8 gig all the time. We hear that all the time, right? Okay. We have other things like other hard drives. For example, I have this hard drive. It's an external hard drive. You see this external hard drive? This external hard drive is 1 terabyte, 1 TB. It's not 500 gig or 200 gig. This one is 1 terabyte. So I can store up to 1 terabyte here. This 1 terabyte, what does it mean? Wait a minute. You have your pen drive that is 64 gig. My hard drive, external hard drive here is 1 terabyte. What does it mean? This 1 terabyte is not 64 gig. It is 1000 gig. Wait a minute. It's not 500 gig. It's not 750 gig. 1000 gig. So 1000 gigabytes is 1 terabyte. Hello. Somebody has more than 5 terabytes hard drive. And the 5 terabyte hard drive is really big. Someone has 16 terabyte hard drive. Wow. 16 terabytes is serious. For a PC to have 16 terabyte. This is serious. You have to be a video editor to be using 16 terabyte. That's a lot of space. Some companies are using more than 1000 terabytes. 1000 terabytes is also given a name called what? Petabyte. So when they ask you how many petabytes or how many terabytes makes 1 petabyte, 1000. So 1000 of this hard drive, 1000 of it will make 1 petabyte. Are you here? In PC, we end our storage at terabytes. For personal computers, we don't go beyond terabytes. But for mainframes and supercomputers and some servers, they may operate in petabytes. Now, just for your knowledge, 1000 petabytes is called 1 exabyte. 1000 exabytes, I've done the research for you, is called 1 zettabyte. 1000 zettabytes is called 1 yottabyte. And if I ask you to find 1000 yottabytes, 1000 yottabytes is called a brontobyte. Brontobyte, have you seen it? All right, please. For now, if you're a beginner, try and learn up to PB. Petabyte is very reasonable because you'll be hearing it from time to time. So just keep that in your mind. Learn up to petabyte for now. For now. When they say kilobyte, don't let it sound confusing to you. What is kilobyte? Don't let it confuse you. When I say something is kilobytes, don't let it confuse you. When something is 32 kilobytes, you should understand it. If you are asked to tell us how many bytes make up 32 KB, you should be able to work that out. Even when they ask you how many bits, they don't ask you that question unless it's an examination that they want to test your mind. But in real life, they don't ask you that. But if they ask you how many bits make up 32 KB, I should be able to work that out. Are you with me? And in everyday life, you are going to see your files in megabytes and kilobytes. And you are going to see your hard drives and some videos in gigabytes. If a file is in gigabytes, it should make sense to you. You should know that gigabyte is more than megabyte, right? When they weigh the two, when they ask you megabyte, gigabyte, which one is more? What will you say? Okay, so let's say 5 megabyte. Okay, 500 megabytes and 5 gigabytes. Which one is more? 505. You choose 5. 505. You choose the 5. Okay, because gigabyte is more than megabyte. You also have to understand that after gigabyte, we go to terabyte. When you hear that someone's hard drive is in terabyte, It means 1,000 gigabytes. Let that be simple in your mind. When someone has 500 gigabytes and someone has 1 terabyte, don't be confused about that. You see, for me, it doesn't even make sense for me to even say it. But sometimes beginners confuse some things. You're confused with some things. Well, I don't know who will be listening, but I just want to say it. Don't let terabytes sound confusing to you. 750 gigabytes and 1 terabyte. Which one is more? 1 terabyte is more than 750 gig. You have a pen drive that is 64 gig. Someone has a hard drive 750 gigabyte. And someone has a hard drive 1 terabyte. Which one is more? The 1 terabyte is more. Because how many gigabytes make 1 terabyte? 1,000. Is that okay? How many gigabytes makes 1 terabyte? 1,000. And as a student, upgrade your mind a little bit, because you are going to, after PC, you should know a little bit more about higher computers. And so in the course of your studies, you are going to encounter petabytes. When you hear PB, don't be shocked. Don't be lost. PB is simple. It means petabyte. When I read and I see something like this, 1 petabyte, I go like, hey, 1 petabyte. Wow. That means this is not even 1 terabyte. To me, 1 terabyte is a lot. Wait a minute. So this is more than 10 terabytes, 100 terabytes, 500 terabytes. What? 700 terabytes? You mean 1,000 terabytes? 1,000 terabytes. Wow, this machine is serious. 1 petabyte. Serious. So at least when I hear petabyte, I can think about it in terms of terabyte and gigabyte. Then I'll know the value. And I'll go like, wow. This machine is petabyte. That's serious. I don't see kilobytes and say, wow. I don't see kilobytes and go like, wow, this machine is kilobyte. Like the video we saw, 64 KB. If they had told me 64 PB, I'll go like, wow. Because I know the value of KB, kilobyte, and I know the value of petabyte. Exactly. All right. So I'll be ending the part 1 of our studies here. Next time we will continue with the part 2, and we will start learning how to calculate. Let me tell you, this lesson is going to be one of the most valuable things you will ever learn in IT. The most valuable thing, if you understand this lesson, it's going to be one of the most valuable lessons you have ever learned in information technology, because it's going to carry you through all of your IT career and your IT education. All at every level of IT, we study more about this. No matter what you want to do in IT, you will learn more about this. So I'm looking for some of you who will understand this. At least I pray that what we have discussed today makes sense to someone. Next time, we will start learning how to count in the system, the number system, and how to calculate in the number system. Then we'll learn how to convert binary system to decimal system. We'll learn how to interpret decimal in terms of binary. When we see any decimal, how do we interpret it in terms of binary? Then we will start learning, listen to me, we'll start learning how to interpret text in binary. When you see text, how do you interpret text in binary? We'll start learning that. And after you learn that, you will know that even your name can be written in binary code. You can write your name in binary code. And after that, you will know that even your telephone number can be written in binary code. So next time when someone asks you for your telephone number, give it to them 0110110011110. You should go and decode it. Alright, so this brings us to the end of part 1. Thank you for joining us in this class, and I'll see you in the next video. Bye.